So here's some information on what's called sigma notation. Now, you've probably already seen the Khan Academy video on sigma notation at this point, and you probably understand over 90% of what's on this page. You will have a chance to pause the video and check all of this out, but first I'll take just a moment to point out some things to you that maybe you haven't learned at this point or that are worth reviewing. So first of all, the symbol we use is a sigma, and that's a capital Greek letter. There's also a lowercase version. We use the capital version to represent the sum or the series. Limits. The book's definition here. Limits are the least and greatest integer values of n in the series. So we have a lower limit and an upper limit for our series in sigma notation. We also use an explicit formula. Of course, in an infinite series, sigma notation, also called summation notation, shows an infinity or infinity sign for the upper limit. And something you likely know, but I would like to review at this point, to find the number of terms in a series written in sigma notation or summation form, subtract the lower limit from the upper limit and add 1. So here's your chance to pause if you'd like to check this out with a little bit more care. Example problem 3, writing a series in summation notation. The question says, what is the summation notation for the series? And notice it's a multiple choice question. Our series is 7 plus 11 plus 15 plus, skip a few, plus 203 plus 207. And we have 4 options. Each of those beginning with n equals 1, so 1 is our lower limit. Some of these have 50 for an upper limit, some have 51, and they each, well, they either have the explicit formula 7n or 4n plus 3. So let's begin checking these and see which would build for us the series given. So here our lower limit is 1, so we would begin by substituting a 1 in place of n. 4 times 1 plus 3 is 7. That seems to work. Then we would plug in 2 for n. 8 plus 3 is 11. This is looking good. A 3 for our third term, our 3 for n is 12 plus 3, 15. Let's check the upper bound, or the upper end. 207, when we substitute in our upper limit, 51, we should get 207 if this is the correct notation. 4 times 51 would be 204 plus 3, 207. And I'm feeling really guilty at this point because we've checked our answers and the first one worked just fine. Let's pretend for a moment we didn't know that yet, or we just wanted to be good mathematicians and eliminate some of our other choices. Let's check C. First we would substitute in 1 for n, and our first term would be 7 times 1, 7. Let me switch colors. So C works for our first term. For our second term we would substitute 2 for n. 7 times 2 is 14. Right away C does not work. How about B? We would substitute in 1. Notice B is really similar to A. The difference is the upper limit, and that looks to be the only difference. So once we got to the point where everything looked good, but we wanted to double check our upper limit and make sure that our upper limit of 50 provided us with a term of 207, we'd substitute 50. 4 times 50 is 200 plus 3 is 203, and we would find that B also does not work. D is very similar to C, so we would run into a similar problem when we got to our second term. N equals 2, 7 times 2 would be 14, and our second term needs to be 11, so D also does not work. A, as we said in the beginning, A is the correct answer. And here's a chance to show that you have got it. Question 1 of 2. What is the summation notation for the series -5 plus 2 plus 9 plus 16 plus, skip a few, plus 261 plus 268? Work carefully and make your selection from the choices below. And got it, question 2 of 2. What is the summation notation for the series 500 plus 490 plus 480 plus ... plus 20 plus 10? Work carefully and make your selection from the choices below. And take note, You should take note. You should add this to your notes. It's a key concept. Summation notation and linear functions. If the explicit formula for the nth term in summation notation is a linear function of n, then the series is arithmetic. The slope of the linear function is the common difference between terms of the series. Example problem 4, finding the sum of a series. What is the sum of the series written in summation notation here? Looks like a lower limit of 1, upper limit of 70, and our explicit formula or expression, 5n plus 3. Let's generate just a bit of this series. Substituting in first 1. 5 times 1 is 5, plus 3 is 8. 2. 5 times 2 is 10, plus 3 is 13. Skip a few. And our upper limit, or our last term, 70 times 5, 350, plus 3, 353. So here we have the information needed to find our first term, well, it's 8, and our a sub n term, in this case a sub 70, 353, and that's the information we need to proceed. So we will recall the formula, which should be in your notes at this point. S sub n equals n over 2 times the sum of our first and last terms. So plugging in what we know, we're going to be dealing with an n value of 70. So that will equal $35 times the quantity, 8 plus 353. And so we need to multiply 361 times 35. And I know what you're thinking. And we actually can do that. Let's consider 35 to be 10 plus 10 plus 10 plus 5. What is the sum of the series written in summation notation? I think we've got it. Part B, we'll discuss briefly. Notice the series is not arithmetic. We have the expression n minus 1 squared. So you can still solve it using more of a brute force technique, where we actually calculate and add each of the terms. And one of 3 chances to show you have got it after that example problem. What is the sum of the finite series shown here? Work carefully and make your selection from the choices below. B, what is the sum of the finite series shown here? Again, work carefully and make your selection from the choices below. And the third got it question. What is the sum of the finite series shown here? Work carefully and make your selection from the choices below. Alright, I'm not going to walk through problem number 5. I recommend that you do. Pause this video and check out this really neat way that your calculator can calculate series for you. And now put those skills to good use in this got it question. Use a graphing calculator. What is the sum shown here? Work carefully and make your selection from the choices below. And your lesson check exercises for section 9.4.